In section 4.2, we're going to look at the amplitude and period of the sine and cosine graph. And we're going to look at how those can be changed. So I have on the screen here the basic graphs for the sine function and the cosine function. You should memorize each of these pictures. Down below here we have some important information about each of these graphs. So we need to remember that sine starts at the origin, goes to its maximum value, back down to the middle, down to its minimum value, and back to the middle again. And it does all this in a distance of 2 pi units. So we say the period is 2 pi. The amplitude is 1 because it goes up 1 and down 1 from the x-axis. So its range of values is all the y values in between -1 and +1. And its domain, of course, is all real numbers because you can take the sine of any angle. Also down here we have the zeros are occurring at x equals k pi. You can see that on the graph here. Your zeros occur at 0, pi, 2 pi, and it goes on forever, 3 pi, 4 pi, 5 pi, etc. For the cosine graph, same situation, except that the cosine starts at its highest value, which is 1, then goes down to the middle, down to its lowest value, back to the middle, and back to its highest value. It does all this in a distance of 2 pi units, which is the period of the cosine graph. Amplitude is 1 because it goes 1 unit above and 1 unit below the x-axis. The range of y values is between -1 and +1. And of course, its domain is all real numbers. Now, what are the zeros? Where does it cross the x-axis? Well, you can see it crosses at pi over 2, 3 pi over 2, and then it would cross again at 5 pi over 2, 7 pi over 2, etc. And so its zeros occur at pi over 2 plus k pi. And let's keep in mind that we can also express this as 2k plus 1 times pi over 2. Remember, 2k plus 1 means some odd integer, and then multiplied by pi over 2. And just for clarity, these are the same. Algebraically, these are the same. Okay, so this is just a brief summary of what we learned in the last section regarding sine and cosine. Now we're going to see how can we affect the amplitude? So on the sine or cosine graph, how can we make it taller or shorter? Let's take a look at an example. So our first example is we'd like to sketch the graph of y equals 2 times the sine of x, and we're only interested in doing this in between 0 and 2 pi. And you'll see off to the side here, I have the basic sine graph. I have this as a reference. Now, to do this for the first time, let's go ahead and make a table of values. So in my table of values, I'm going to plug in the x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, and we'll calculate the corresponding y values. So for example, when x equals 0, we know that y is going to be 2 times the sine of 0. And this is 2 times sine of 0 is 0, and 2 times 0 is 0. So our first point is at 0, 0. If x is pi over 2, y is going to be 2 times the sine of pi over 2, which is 2 times 1, which is 2. So when x is pi over 2, y is going to be up here at 2. So you see that it goes higher than normal. And of course, that 2 is because of the 2 in front of the function. If you plug in pi, you're going to get 0 because the sine of pi is 0. So that's going to be this point here. If you plug in x equals 3 pi over 2, the sine of 3 pi over 2 is -1. And then -1 multiplied by 2 is -2. So at 3 pi over 2, the y value is -2. And if you plug in 2 pi, the sine of 2 pi is 0, and 2 times 0 is 0. And so that puts us back to here. So what does this graph look like? Well, we can sketch it. It goes up to its highest value, which in this case is 2, back down to the middle, down to its lowest value, and back up to the middle again. And this is what the graph of 2 times the sine of x would look like. Now, keep in mind that this graph continues, so it continues to go on forever in this direction and also in this direction. So if we were to continue that pattern just to show it, at 5 pi over 2, it would be at 2 again, so the graph would continue up like this, and then it would begin its downward journey. And over here on the other side, if x is negative pi over 2, we would get this value, and it would continue its journey here. So they only asked for the graph between 0 and 2 pi, which is what I have outlined here. Now for this next graph, I'm going to try to shorten the process a little bit because this isn't terribly difficult to understand. Here I want to sketch one complete cycle of the graph y equals 1/2 cosine of x. So here is your basic cosine graph for reference. Normally when x equals 0, cosine of 0 is 1 and you get y equals 1. But if you just imagine for a minute, if you plug in x equals 0 here, the cosine of 0 is 1, but then that is multiplied by 1/2. So what happens here is instead of having your normal y value equal to 1, your y value for this function is going to be 1/2 when x is 0. Now at pi over 2, at this value here, it's going to go ahead and hit the x-axis because cosine of pi over 2 is 0. Cosine of pi is -1, but when you multiply -1 by 1/2, you get -1/2. So at pi, we're at -1/2. At 3 pi over 2, we're at 0 again. And at 2 pi, we are at 1/2 again because the cosine of 2 pi is 1. So this graph, when you sketch it, looks like this. So it looks just like the cosine function, but it's a little bit shorter. And the amplitude of this graph is equal to 1/2. Now, I can graph the regular cosine graph on top of this to kind of help you see what happened here. So our regular cosine graph goes down like this, goes down to -1, back up here, and back up to +1. So this is y equals cosine of x. And so again, you can see that y equals 1/2 cosine of x is just a little bit shorter version of the same graph. Same period, everything else, but just shorter. So if we generalize the results of the last two examples, we can say that if a is a positive number, the graphs of y equals a times the sine of x and y equals a times the cosine of x will have amplitude a. So they're the same as the original graphs, but just taller or shorter, depending on whether a is bigger than 1 or less than 1. So for this problem here, I'm going to graph both of these on the same set of axes. And again, I have for reference the basic cosine graph and basic sine graph off to the side here. We're going to start graphing using black the function y equals 3 cosine of x. So as you can see over here, cosine normally starts at its high point, which is normally 1. But now it's going to start at a high point of 3 because the amplitude of this graph is going to be 3. Now we know that at pi over 2, cosine is 0. At pi, cosine is -1, but now it's going to be -3, again, because the amplitude has been magnified here. And at 3 pi over 2, it's 0. And at 2 pi, it's back up at 3 again. So the graph of 3 cosine of x, when you sketch it out, looks like this. Now let's talk about the graph of 1/4 times the sine of x. Well, this is going to look like the sine function, which is down here. So it will start at the origin, and then it will go to its high point, and then back to the middle, and then down to its low point, and finally back to the middle again. But look at its amplitude. its amplitude is 1/4. So what we have to do here is find 1/4 on the y-axis. So here's 1/2. 1/4 is right about there. And here's -1/2, and -1/4 is right about there. So that is as tall as this graph is going to get. So again, what does sine look like? Well, think about the 5 important points here. It starts at the origin, and it's going to be on the x-axis at those 3 values. So that's going to be here, here, and here. And then halfway in between these values, you're going to have your high point and your low point. And your high point is going to be 1/4, which is right there. And your low point is going to be -1/4. And so this graph is very, very short and almost is kind of hard to graph because of that fact. So again, the first one that we did, this was y equals 3 cosine of x. And the second graph we did was y equals 1/4 times the sine of x. Now we're going to look at how we can change the period of a graph. So instead of a cycle occurring between 0 and 2 pi, how can we either lengthen or shorten the distance for that cycle? So let's consider y equals the sine of 2x. So now instead of a number in front of sine, we have a number in front of x. To understand what happens here, what I'm going to do is make a quick table of values. So we have our x values and our y values. And I'm going to pick some special values for this one to help us see what happens here. I'm going to start with x equals 0. And then normally we would go to pi over 2. I'm going to do pi over 4 instead. And then pi over 2. And then 3 pi over 4. And finally we'll end with pi. Let's see what happens when you plug these numbers in. So when x is 0, y is going to be sine of 2 times 0, which is the sine of 0, and the sine of 0 is 0. So that's fine, that's this point here. When x is equal to pi over 4, y is going to be the sine of 2 times pi over 4. 2 times pi over 4 is pi over 2, and we know the sine of pi over 2 is 1. So at pi over 4, which is this value right here, we have a y value of 1. When I plug in pi over 2, y is going to be sine of 2 times pi over 2. And the 2's cancel there, and we just get sine of pi. And sine of pi is 0. So at pi over 2, we are at 0 again. And then if I plug in 3 pi over 4, y is going to be the sine of 2 times 3 pi over 4. This is the sine of 3 pi over 2, and we know the sine of 3 pi over 2 is -1. So at 3 pi over 4, which is this value on the x-axis, sine is -1 in this case. And if I plug in pi, y is the sine of 2 times pi, and sine of 2 pi is 0. So at pi, we are at 0 again. So if you look at what happened here, we have the sine graph just like normal, but normally the sine graph won't complete one cycle until we get to 2 pi. So what I hope you see here is that the period of this graph was decreased. So instead of being 2 pi, the period is now just pi, because this is pi units, right? That distance is pi units. So if I go ahead and complete this graph, what's going to happen is between pi and 2 pi, we're going to get another full cycle. So at this value here, it's going to be up at 1. Here it's going to come back down to the middle. At this value, it's going to be down at -1, and then back to the middle again. And you can see that if you graph this correctly, you will get this nice, smooth, evenly shaped curve. So what happened with the 2 here is it took the normal period, which is 2 pi, and it divided that by 2. Okay, and we'll summarize the results. So the summary is as follows. the graphs of y equals a times the sine of bx, or y equals a times the cosine of bx, where a and b are positive numbers, will have amplitude a, we already talked about that, but the period will be 2 pi divided by b. So this allows us to graph a little bit more efficiently if we have that knowledge. So let's take a look at this example. We want to graph y equals the sine of 3x. Let's keep in mind what the regular sine graph looks like. So I brought it in here just for reference. So sine normally starts at the origin, goes high, and then goes low, and then back. So now I want you to notice, first of all, the amplitude of this graph is 1, because a is equal to 1. So the amplitude is 1 for this one. But the period is 2 pi divided by the number in front of x. And that number in front of x is 3. So if I do 2 pi divided by 3, I get 2 pi over 3. So what this means is when we graph our sine function, it's going to have the normal sine shape. It's going to start here at the origin at 0, but it's going to complete one full cycle from here to here, because notice this value is 2 pi over 3. So from 0 to 2 pi over 3 is one full cycle. So what does the sine graph look like? Well, remember, sine starts at the origin, and it also ends at that same level, and halfway in between is at that level. So it's going to start here, the first cycle is going to end here, and halfway in between it's going to also be on the x-axis. And then you have the high point and the low point. So halfway in between these, you will have a high point here and a low point here. And this is what this graph is going to look like. So now we'll sketch that. Okay, that's what it looks like. But see, now I want to go ahead and extend this out. They ask us to extend it out between 0 and 2 pi. We're going to extend it out for the entire graph that you can see here. So the next cycle, what's the next cycle going to look like? So now we're just picking it up from this spot. Well, another 2 pi over 3 units is going to be from 2 pi over 3 to 4 pi over 3. So it's going to hit here at the end, it's going to hit here in the middle, it's going to go high here, and it will go low here. So it goes high, middle, low, middle. And we can keep doing this. If I extend it again, it's going to hit here and here. Halfway in between, it'll be high here. Halfway in between, it'll be low here. It goes high, middle, low, middle. And we can keep going and going and going in both directions. So going the other way, we know it's going to hit here and here. Go with the flow, right? So this graph is coming down. So it's going to go down to its low point, back to the middle, up to its high point, and back to the middle again. So to summarize, it's going to go through these points here. And I could keep on going. It's going to hit 2 more times there. It's going to hit 2 more times there. It's going to hit another time there. And then halfway in between at all these points, it's going to be a low point, a high point, a low point, a high point, and a low point. So what you notice is I'm graphing all the important points first, and then sketching them is just a matter of connecting the dots. Now let's go ahead and graph one complete cycle of y equals cosine of 1/2 x. So again, I want you to notice that there is a 1 in front here, so the amplitude of this graph is 1. But the period of this graph is 2 pi divided by the number in front of x, and that number is 1/2. And 2 pi divided by 1/2 is 2 pi times 2 over 1, and that is 4 pi. So the period of this graph is 4 pi. The amplitude is normal, it's at 1. And now we just need to sketch it according to how cosine behaves. So let's go ahead and bring in the cosine graph. So there it is for reference. What does cosine do? Well, at 0, cosine starts at its high point. So it's going to start at whatever its amplitude is. In this particular case, its amplitude is 1. So it's going to be there. Now, where is it going to complete one full cycle? Well, normally it completes a full cycle in 2 pi units, but the period here is 4 pi. So it's not going to be until 4 pi units later that it will be at that same level. So notice that cosine starts high and ends high. And it will be the same thing here, but the ending will occur at 4 pi because the period is 4 pi. Halfway in between those two high points, we're going to have a low point, which is going to occur at 2 pi. And then halfway in between the highs and the lows, that's where it crosses the x-axis. So what does this graph look like? Well, it looks like a cosine graph, but you'll notice that it is extended. Now the period doesn't complete itself until you get all the way out to 4 pi. And that's because the period here is 4 pi units. And just like before, you could extend this a little bit further. So if you wanted to go beyond here, just take notice. Notice that the distance on the x-axis between any two important points is pi units, right? So from the high point to the middle point, that's pi units. From the middle point to the low point, that's pi units, etc., etc. So here from 4 pi to 5 pi, that's pi units. So we're going to go from our high point down to our middle point here, and then from our middle point to our low point. So if I was to continue graphing this for what you see on the screen here, it would look like this. And then if I were to go in the other direction, we would have a point here, and the graph would come down and touch there. So that's what the graph would look like if you filled out all of the graph that we had available to us. So in this next one, we're going to combine the concepts now. We want to graph one complete cycle of each of the following, and there's going to be 3 problems here. This is the first one. First, we want to graph y equals 3 times the sine of 2x. And now I'm going to do this without writing down or without showing you the basic graph for sine. Instead, we're going to write down the important information. The amplitude of this graph is 3. The period of this graph is 2 pi divided by the number in front of x, which is 2. And 2 pi divided by 2 is pi. So the amplitude is 3. That's how tall the graph is going to be, both above and below the x-axis. And the period is pi. That's how long it's going to take to complete one cycle. So to complete one cycle, it's going to start at 0. It's going to end at pi. Sine starts in the middle, ends in the middle, and also halfway in between is in the middle. And then halfway in between here and here, you're going to have its high point, which is normally 1, but now its high point is going to be up here at 3 because of the amplitude change. And halfway in between here and here, you will have its low point, which will be at -3. So this is what one cycle of this graph looks like. Okay, now they ask us to extend the graph between -pi and 2 pi. I'm going to extend it for everything you see here. So I'll do the rest of the graph in a different color just so I can show you that, this is our first cycle here. And we get everything else by looking at that now. So to get another cycle, we're going to have a point here and a point here. We're going to have a high point here and a low point here. Again, the distance between pi and 2 pi is pi units. That's the period again. So it goes up, back down, and then back up again. And then we'll have a point here and here, and then again a high point here and a low point here. And it goes up, back to the middle, to the bottom, and back to the middle again. And in the other direction, same thing. So another pi units going this way is from 0 to -pi. So we're going to hit here and here. But now, go with the flow. We're coming off of a high point here, so we're going to be headed toward a low point halfway in between. So we'll have a low point down here, and the high point will be here. So it goes low and then high. And then a couple more points here, and then low and high again. And finally, a couple more points here, and we're going to go low and high again. And this is what the graph would look like between negative 3 pi and positive 3 pi. In our next example, we are asked to graph between negative 4 pi and positive 4 pi. We'll just go ahead and graph for the whole thing here. Let's outline the important information. The amplitude of this graph is 4, and the period for this graph is 2 pi divided by 1/2, and 2 pi divided by 1/2 is 4 pi. Now this is a cosine graph, so we're going to have one full period starting at 0 and ending at 4 pi. Cosine, remember, doesn't start at the origin. Cosine starts at the high point, and the high point is going to be up at 4. At 4 pi, it's going to end at that same level. Cosine starts high and ends high. Halfway in between, it will be down here at negative 4, and halfway in between those values, it will cross the x-axis. And so the first cycle of this graph looks like this. Okay, and if you want, you can check it versus the regular cosine graph. But again, you need to know that cosine starts high, goes down low, and then comes back high again, right? That's one full cycle. Now, I can take this in the other direction. So from 0 to negative 4 pi will be another full period. It's going to start high and end high for that one as well. Halfway in between is at negative 2 pi. That's going to be its low point. And then it will cross here and here. And so it will go like this. And I don't have much more, but if I were to extend this a little bit farther, it would cross here. And over on the other side, it would cross here. So you can see I've completely filled out the entire x-axis for what I was given. And that's what I want you guys to strive for, is filling out the entire axis for what you've been given. For our third example here, we have y equals 2 times the sine of pi x. A little bit interesting with this pi here in front of the x. No matter, we know that the amplitude is 2. And we know the period is 2 pi divided by, once again, the number in front of x. Well, the number in front of x is pi. So when we do 2 pi divided by pi, we get 2. So this is kind of unique, but the period here is a whole number. It's just the number 2. Now you'll notice on my axis, I've already accounted for that. So normally we have pi's on the axis. Here we just have regular whole numbers. That's because this period is 2, so I want my graph to match what I'm actually graphing. So how does sine look? Well, sine starts at the origin. It's going to complete one full cycle between 0 and 2 because the period is 2. So it's going to end here, and in the middle it's going to be there. And then the high point and the low points are going to occur at 2 because the amplitude is 2, right? So halfway in between here and here, we have a high point up here. And halfway in between here and here, we have a low point down there. So this is going to look like this. And that's the first cycle. Now they asked us to graph between -3 and +3. So we'll go ahead and finish this graph. I'll do it in a different color. Now, when you go from 2 to 3, that's not another full cycle, right? Because a full cycle occurs in 2 units. So if I go from 2 to 3, that's only 1 unit. That's going to be a half of a cycle. It's going to be this part of the cycle. So yes, we're going to hit here, and then halfway in between, we'll be at the high point. It's going to go like this. And now on the other side, same thing. 2 units this way, we're going to have a full cycle there. So we'll hit here and we'll hit here. We'll have a low point down here and a high point up here. And as we graph that, this is what it looks like. And then we have another unit here that's going to be a half of a cycle. And that comes down like this. And so I've completely filled out the x-axis for what I've been given. And again, I like to do the original first cycle in a different color so you can kind of see we just took this cycle and then we built out on it in both directions. All right, so one final summary. We're going to say that the graphs of y equals a times the sine of bx and a times the cosine of bx has an amplitude of the absolute value of a and a period of 2 pi divided by b. Okay, so we are assuming that b is a positive number, but a could be a negative number. So if you have a number in front of sine or cosine that is negative, the amplitude is still just the absolute value of that number. So let's take a look at an example. If I want to graph y equals negative 2 times the cosine of x, I'm going to note that the amplitude for this problem is the absolute value of negative 2, which is 2. So that just means that this graph is going to go up to 2 and down to negative 2. The period for this graph is 2 pi divided by the number in front of x. Well, the number in front of x is 1. So this is just 2 pi divided by 1, which is 2 pi. So it has a normal period. But then you have a negative in front. Well, what the negative does, and you can see it right here, is it says that if a is negative, it reflects over the x-axis. So let's think about this for a minute. Cosine graphs start at the high point. So the amplitude is 2, means the cosine graph would normally start at 2. 2 pi is the period, so it's going to end at that same level. And then halfway in between, it will be at its low point. And halfway in between there, it will cross. So this is what it would look like if it was y equals 2 cosine of x. But we don't have 2. We have negative 2. So what happens is this graph gets reflected about the x-axis. So what that means is that instead of starting up here, it's going to start down here. And instead of ending up here, it's going to end down here. So it just flips the whole graph upside down. And then, of course, instead of being down here, it's going to be up here. And it's still going to cross the x-axis at the same place here and here. But you can see it's just the cosine graph, but flipped upside down. And then if we want to extend this graph between negative 2 pi and 4 pi, actually, I'll just extend it for what we have here. Another 2 pi units is going to give us another graph. So it's going to start here and end here for the second phase. It's going to be high here, and it's going to cross here and here. So it looks like this. And if we go in the other direction, another 2 pi units is going to be here. Halfway in between, we'll have high point here and then crossing here. So it goes like so. And another 2 pi units will have another cycle. So again, wherever I am here, if I take the distance of the period, I'll be at that same level. Halfway in between is going to be on the opposite side, and halfway in between those, it will cross yet again. And this is what it would look like between negative 4 pi and positive 4 pi. And if you really want to extend it here, you can see that the distance from a high point to a low point is pi units. So when I go an additional pi units here, I'm going to go from a low point up to a high point. So we'd have a high point here and a crossing there. And same thing in the other direction. We'll go from a low point to a high point here with a crossing here. And that is what the graph looks like. So really, this just takes a little bit of practice. Once you get used to it, dare I say it, it's really easy to graph sines and cosines once you get used to the process. So you just got to make sure you get plenty of practice.